In this folder, we're going to start to get into sensation. So if I were to give you a definition for sensation, I would say it's our body's ability to detect what's going on in the world around us. And there are two different types of sensation that we're capable of. So the first of these is what's known as general sensation or general senses. And this is our body's ability to pick up tactile sensations. So when I say tactile sensations, what that means is things that you feel with the skin. So that would be things like touch, changes in temperature, pressure, vibration, those things that are picked up by receptors in the skin. If you look at this diagram here, this one on the left, this is a segment of the skin, so hopefully it looks familiar to you. You may remember when we first talked about the skin that we talked about Pacinian corpuscles and we talked about Meissner's corpuscles. These are two receptor types that are located in the skin that allow us to be able to detect pressure when somebody touches our skin or something touches our skin. These particular receptors are really simple in structure. So really they're just the dendritic end of a neuron that is encapsulated. It's got a connective tissue sheath that surrounds it. The other type of sensation are what are known as the special senses. So the special senses have receptors that are much more complicated than the general senses do. And what we see with the special senses is that the receptors really are more like sensory organs. So they're made up of multiple tissue types. They've got some complexity to their structure. The special senses include smell, taste, hearing, what's known as equilibrium, which is kind of our body's ability to detect posture and balance and those kinds of things. And then vision is considered to be a special sense as well. So what we'll do as we first get into this section on senses is we'll talk about the general senses and we'll have our first folder and activity dedicated to that. And then we'll continue and we'll look at the special senses. So we'll look at each one of those in turn. Before we get into the senses in any more detail, I want to spend a little bit of time talking about the receptors that are located throughout the body that allow us to detect changes, both outside of our body and inside of our body, and talk about how these receptors are classified, because you're going to be hearing these terms quite a lot as you work through the activities in class and as you do the reading and the Learn Smarts and the other assignments. There are three different ways that we can classify sensory receptors. So the first way, and probably the most common way, is just by the type of stimulus that they are most responsive to. When we classify receptors by the type of stimulus that they're most responsive to, there are 5 different categories, and I want to talk about each one of these categories and really what they're picking up or what they are specifically responding to. So the first type of receptor, when we classify them by stimulus type, is what's known as a chemoreceptor. And as their name implies, what chemoreceptors respond to are chemicals, but specifically chemicals that are dissolved in solution. So a chemical that's dissolved in a liquid. Here's an example of what I mean by that. One of the activities that you're going to do in class when you start to learn about the special senses and specifically about taste and smell is you're going to dry your tongue off and you're going to sprinkle some sugar on it once you've dried all the saliva off of it. And what you'll notice when you do that is you can't taste the sugar. And the reason for that is you have chemoreceptors on your tongue. And in order for those chemoreceptors to be activated by chemicals, those chemicals have to dissolve in solution. So what that means is if you want to be able to taste sugar, the sugar has to dissolve in your saliva. And then once you've got a chemical sugar dissolved in a solution or a liquid saliva, now the chemoreceptors that are on the tongue are capable of responding to it and you'll be able to taste it. So chemoreceptors, as their name implies, respond to chemicals, but more specifically, and this is key, they respond to chemicals that are dissolved in solution. The second type of receptor when we classify by stimulus type is what's known as a nociceptor. So nociceptors are located throughout most of the tissues of the body, with a few exceptions, and they are pain receptors. So they are activated when damage is actually done to tissues. That's what activates a nociceptor, and it causes us to feel pain. Thermoreceptors, as their name implies, respond to changes in temperature. So when you jump into a cool pool in the summer, or you get into a hot shower and you feel those changes in temperature on your body, that's being picked up specifically by thermoreceptors, which again are a receptor type that respond to changes in temperature. Mechanoreceptors respond to changes in pressure. So this could be stretch, for example, on an organ. In the lungs, we have mechanoreceptors that detect stretch as the lungs are inflating, as we're inhaling. In the stomach, we have mechanoreceptors that detect stretch there. For example, when you're eating and your stomach's starting to become full, to let you know that your stomach is stretching and that you're full. So mechanoreceptors are found throughout the body, and their job is to detect changes in mechanical pressure, which a good example of is stretch. Photoreceptors are found in one specific place in the body, and that's in the eye. A photoreceptor responds specifically to light, so they are activated by light. Another way that we can classify these receptors is based on their location in the body. So sometimes you'll hear receptors that are located deep within organs, for example, referred to as interoreceptors, whereas receptors that are located more exterior, maybe in the skin, would be called exteroreceptors. So just to give you a couple of examples of that, I talked about some mechanoreceptors, some stretch receptors that are located in the stomach. That's really internal. It's within an organ of the body. That would be a good example. Interoreceptor, the Pacinian corpuscles, the Meissner's corpuscles, your eye, these structures that are located at the surface of the body or very close to the body's surface are good examples of exteroreceptors. The last way that we can see sensory receptors being classified is based on their anatomical or their structural complexity. So I talked about this a little bit previously in the fact that the receptors that we have in the skin that are picking up changes in pressure, so Pacinian corpuscles, Meissner's corpuscles, for example, are really simple in their structure. Really, they're just the dendritic end of a neuron that's enclosed in a capsule. I also talked about the fact that with the special senses, so remember that smell, taste, equilibrium, hearing, and vision, we've got these receptors that are really much more complex, as you can see by looking at this diagram of the eye. So with the special senses, generally our receptors are multiple neurons, they've got multiple tissues, it's really a sensory organ that's much more complex in its structure that is picking up sensations when we're talking about the special senses. So the last general information that I want to give you about sensation before kind of turning you loose and getting you started on the activities for this week is I wanted to talk a little bit about sensory adaptation. Sensory adaptation is the ability that we have to ignore unimportant stimuli. So we don't pay attention to things like our hair being pulled back in a ponytail, like our belt at our waist, like our sweater on our arms or our socks that are pulled up. We don't pay attention to those things because they're not really important. And if we were aware of them all the time, it would absolutely drive us crazy. So our bodies have the ability to do what's known as adaptation, and that means that a receptor for a particular sensation just stops responding to the sensation so that we're not constantly aware of it and constantly bothered by it if it's something that's not important. Some of the receptor types that we've talked about are capable of fast adaptation. So what that means is very quickly after they're exposed to a stimulus, they stop responding to that stimulus because it's just not important. So thermoreceptors that I mentioned are there to detect changes in temperature in the body would be a good example of this. You probably had the experience of jumping into cool water in the summer, and when you first get in, it feels really, really cold on your body. And then you'll notice 10 to 15 minutes later, you don't really notice anymore that there's a temperature difference. It doesn't feel so cold. A lot of us experience the same thing when we're showering. So I tend to be a person that gets into the shower, it feels really hot at first, and then I kind of adapt to it, and maybe I even turn up the temperature of the water over time throughout that shower because it doesn't feel as warm anymore. The reason for that is these thermoreceptors are capable of fast adaptation, so they respond very quickly. Now, if you got into ice cold water or you got into burning water, you're not going to adapt to that, because in those situations, it's not just thermoreceptors that are being stimulated, it's nociceptors as well, because you've actually got tissue damage that's going on. And nociceptors do not respond. They do not adapt for reasons that we'll talk about in a minute. Meissner's corpuscles, Pacinian corpuscles, so those simple receptors that are located in the skin that respond to touch, pressure, they are good examples of receptors that are also capable of fast adaptation. So you're wearing clothes probably right now, you're not constantly aware of the sensation of those clothes on your body because those receptors that are located in the skin stop responding. They stop making your brain aware of that information because it's just not important. I mentioned previously that there are a couple of receptor types that do not adapt, and this is for the safety of the body. So the first of these are nociceptors. When I talked about nociceptors before, I mentioned that they respond to tissue damage. So if you're doing something or something's happening that's causing damage to the body, nociceptors are being activated and you're going to get a sensation of pain from that. Nociceptors do not adapt because if tissue damage is happening, that's always important to know. If they were to adapt, that would allow the situation where further damage could be caused to the body, which potentially could be really harmful to the body. The other type of receptor type that doesn't adapt is what's known as a proprioreceptor. So proprioreceptors are a type of mechanoreceptor. Remember, mechanoreceptors respond to changes in pressure in the body, and I talked specifically about the example of stretch, how they're picking up stretch in the body. Proprioreceptors are stretch receptors that are found in a few specific places within the body. So they are found in muscles, they're found in tendons, they're found in ligaments, and they're found in joints as well. And they do not adapt. And the reason for this is protective to the body as well. If you are, for example, standing off kilter or your balance isn't good, one of the ways that your body's going to be alerted to this is you're going to get stretched through muscles and tendons and ligaments and joints. That's important information to know if you're getting stretched through muscles, tendons, ligaments, and joints, because if we don't do something to rectify your posture or rectify what's causing that stretch, there is a likelihood that you're going to end up with an injury. So a proprioreceptor is another type of receptor that does not adapt along with nociceptors because it's going to help to protect your body from injury.